Let's go ahead and get started. First thing I'll do is I'll cover material. I'll do that for about an hour and a half, hour and 15 minutes, however long it takes. And then I'll answer questions during the last part of the meeting. Now, some of this I'll skip over just because we don't have time to cover all the different topics. And I'll try to focus on the ones that maybe you need a little refresher on. The square roots and cube roots, let's talk about those. If we got the square root of 16, that's what this symbol is, square root, we try to write the prime factorization of the number, 16. Or, if you can think of numbers multiplied together, that gets you started. 16 is 4 times 4. Now we're looking for a pair of somethings, so this pair of 4s is going to come out in front as a single 4. And that'd be our answer. On the other hand, if we have square root of 20, and one way you can do the prime factorization is you can do the tree breakdown. You start with your first prime, which is 2, and you ask yourself if it's divisible by 2, and it is. 2 times 10. 2's prime size circlet, and then you go to the 10. It's 2 times 5. And 2's prime size circlet and 5's prime size circlet. So square root of 20 is 2 times 2 times 5. Now we're looking for a pair of somethings. Here again is a pair of 2's, so they're going to come out in front as a single 2. And we're left with 1 5 inside, and we can't bring it out because there isn't a pair of them. And that'd be our answer. Now on the other hand, if you have a cube root, just talking about the cube roots, well, the cube root of 54, first thing we'll do is we'll do the prime factorization. For 54, we have 2 times 27. 2's prime, so we circle it. And 27 is divisible by 2, so go to my next prime, which is 3. 3 times 9. And 3's prime, so we circle it. Now on the 9, it's still divisible by 3. 3 times 3. And the 3's prime, so I circle them. So 54 becomes 2 times 3 times 3 times 3. Now since this is a cube root, this number in the slot here is called our index. That tells us how many we're looking for. So it says we're looking for a set of 3 of something. Here's 3 3's, so they're going to come out in front as a single 3. And we're left with a 2 inside. And that would be our answer. Now let me clear this off. And let's talk about the order of operations. There's a way to remember what to do. It's please excuse my dear Aunt Sally. And the first letter of each tells you what to do. Okay, the P. This tells us to do what is inside of parentheses, P for parentheses. Even more than that, included in there is brackets and absolute value. I have seen some books that actually include braces in there also. You don't see that as often though. The E is for exponents, so do any exponents. MD, that's standing for multiplication or division. So you're going to multiply or divide as you encounter either one from left to right. And Aunt Sally, AS, you're going to add or subtract as you encounter either one from left to right. So if we take a look at a couple examples. Okay. Please, we do what's inside the parentheses. Now, if there's multiple operations inside the parentheses, you still follow your order of operations. There's no parentheses inside the parentheses. Please excuse exponents. So I'm going to do this 2 squared first. Everything else carries down. And 2 squared is 4. Still doing what's inside the parentheses. There's no more exponents. My dear, multiplication, division, no. Aunt Sally, addition, subtraction. You do it as you encounter from left to right. So we're going to do the 3 minus 1 first. 3 minus 1 is 2, and then I'll carry it down to 4. And there's only one operation left inside the parentheses, 2 plus 4. So we're going to have 5 minus 2, and 2 plus 4 is 6. A lot of people are under the impression that the please part of the order of operations says get rid of parentheses. And that's not what it says. It says do what's inside the parentheses. Now you may end up getting rid of the parentheses at that point, but that's not its main goal. We did everything inside the parentheses, and I have to keep them here because that 2 right next to it indicates multiplication. Okay, and I'm looking back at my original problem again, the entire thing. There's parentheses, but we already did everything inside of it. Please excuse exponents. No, there's no more exponents. Multiplication, division. So we're going to take 2 times 6. Everything else carries down. Gives us 12. Aunt Sally, addition, subtraction. 5 minus 12 would give us negative 7. And that's our answer. Now one more. This is going to demonstrate what is the exponent effect. Okay, please. There are parentheses, but there's nothing to do inside the parentheses. Excuse exponents. Well, our first exponent from left to right, we always do things from left to right, is right here. Now, your exponent only affects what's to its immediate left unless there's parentheses. Then it affects everything inside the parentheses. So this second power here only affects the 2. It does not affect the negative. The negative just carries down. 2 squared, 2 times 2 is 4. Plus negative 3 squared. Now we still have one more exponent. And remember, your exponent affects what's to its immediate left unless there's parentheses, and then it affects everything inside the parentheses. So this second power is going to affect everything inside. So negative 3 squared, negative 3 times negative 3 is a positive 9. Let's see, please excuse my dear. There's no multiplication, division. Aunt Sally, addition, subtraction. Negative 4 plus 9 is going to give us 5. And that would be your answer. Now we get down to here. There's algebraic models, identify terms and coefficients, apply properties. We're specifically going to look at simplifying algebraic expressions. So I'm going to clear this off. And let's say I had this algebraic expression, 5x squared minus 7x plus 2 plus 2x squared minus 3x minus 8. Now these are talking specifically about terms and coefficients. That's what these are referring to. So when they say simplify, well, we're going to focus on adding and subtracting like terms. Simplifying algebraic expressions, that could mean a lot of different topics. That's why you have to look at what's above it. Now these parentheses aren't doing anything, so I can drop them. And we have something called like terms. Like terms is where you have the same variables to the same power. So back to here, we have our x squared and we have an x squared. These are like terms. They're both x to the second power. To combine like terms, you add or subtract the numbers in front of them. We got 5 plus 2 gives us 7x squared. Now here's an x and here's an x. Since they're both x to the first power, remember there's no power, there's a 1 there, then we'll add or subtract the numbers in front. Negative 7, negative 3 gives us negative 10x. And we have 2 minus 8. Included in like terms where you have numbers. 2 minus 8 is negative 6. And that's our answer. Now if I had a minus in between, well, first off, this first set of parentheses isn't doing anything, so I can drop it. So I got 7x squared minus x plus 3. And remember, a negative in front of your parentheses flips the sign of everything inside. Terms are separated by pluses and minuses, so there's 3 terms in here. And that's going to flip the sign of all of these. So the positive 2x squared becomes a negative 2x squared. The positive 6x becomes a negative 6x. And the negative 5 becomes a positive 5. No matter where you are in algebra, you should always combine like terms, combine together numbers. Here we got 7x squared minus 2x squared. 7 minus 2 is 5, so we're going to have 5x squared. Here we have a negative x and negative 6x. Remember, when you don't have a number in front of the x, there's the invisible 1. That's a coefficient. So we got negative 1 and negative 6. That gives us negative 7x. And we got 3 plus 5, which is going to give us 8. And that would be our answer. Now, one more topic I just want to discuss here is a distributive property. It kind of goes along with terms. If I have something looks like this. When you got a number in front of your parentheses, that indicates multiplication. When you got anything in front of your parentheses, that indicates multiplication. And we use just the distributive property here. We're going to take this single number here, or it could be a single term, and we'll multiply it times each term inside. Now here, we're going to take the negative 2, and we'll multiply it times each term inside. So we're going to have 3 times x. Just follow in line and see what to multiply together. And I'll have 3 times 7. Over here, I follow lines. We got negative 2 times 3x. And we got negative 2 times negative 8. That gives us 3x plus 3 times 7 is 21. Minus 2 times 3 is minus 6x. Negative 2, negative 8 gives us positive 16. And as always, combine together like terms in any step. So we got 3x minus 6x. That gives us negative 3x. And we got 21 plus 16, which gives us 37. And that would be our answer. Now, section R.3, integer exponents. We're going to talk about some of the different properties, refresh your memory. It says simplify expressions with 0 negative exponents, apply properties of exponents, and apply scientific notation. We won't focus on scientific notation, but we'll focus on the first 2. Let me clear this off. Grab a drink while I'm at it. Okay. Say we have x squared times x to the third. If I think about what x squared represents, that's x times x There's 2 x's. This is the second power. The x to the third. That means there's 3 x's. Now if I look at this, there's now a total of 5 x's. Well, the property on this is if you got x to a power times x to a power, you add the exponents. 2 plus 3 is 5. Let me write that over here. So x to a power times x to a power, you're going to add the exponents. For example, if we add x to the 7th times x to the 5th. X to a power times x to a power, you add the exponents. 7 plus 5 is 12. And that would be your answer. Now, let me get rid of those. I shouldn't put a 1 there, but I'm going to erase that also. Now, if I have x to a power raised to another power, I could write so you can read it. There it goes. What that means, x to the third to the second power means you're going to take x to the third times x to the third. Now x to the third means I got 3 x's. X to the third here means I got 3 x's. And you can see we have a total of 6 x's now. When you're raising one exponent to another exponent, you multiply them together. The way the property officially looks is if you got x to a power raised to another power. That's the n power. This is m. Then you would multiply the exponents together. So if I had x to the 7th raised to the 10th power. We're raising one exponent to another exponent, so we're going to multiply them together. So you got x to the 7 times 10, or x to the 7, 70th. And that would be your answer. Now if you have anything to the 0 power, doesn't matter what it is, a number, anything to the 0 power is always 1. And that would be your answer. So that's how you handle 0 power. Now negative exponents. We never want negative exponents in mathematics. And we always get rid of it the same way. First off, if it's not in fraction form, you have to create a fraction. So I'll put this x to negative 5, put it over 1. How you get rid of a negative exponent is you take the part with a negative exponent opposite of where it's at in the fraction. So this x at negative 5, I'll move it down below. When you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So the x at negative 5 becomes x to the positive 5. And you never leave blank in a fraction, so that's a placeholder. You always put a 1 there. And that'll be your answer. Now on the other hand, if I already have the negative exponent in the denominator, down below. Same idea, you take it opposite of where it's at in a fraction, so we take the x and negative 2, move it up on top. When you move anything opposite where it's at in a fraction, the sign of the exponent changes. So the x and negative 2 becomes x to the positive 2. Over, and again we never leave blank, so we'll put a placeholder of 1 there. And x squared over 1 is x squared. Now you'll combine, in some cases, these together. For example, if I have y squared x to the negative 3, and I'll have y to the negative 5 x to the 12th. Well, first off, we never want negative exponents. So we'll take these x to the negative powers, or x to the negative power opposite of where it's at, and we'll take this y to the negative power opposite of where it's at. Again, when you move anything opposite of where it's at in a fraction, the sign of the exponent changes. The y squared we didn't move, so it stays y squared. The y to the negative 5, when I move it up on top, it becomes y to the positive 5. Now here, the x to negative 3, when I take it down below, it becomes x to the positive 3. And then at this point, like I said, you combine together properties. We already talked about what happens when you got y to a power times y to a power. You add the exponents. That's y to the 7th. We worked with x's, but it doesn't matter what your variable is. It can even be a number. Here we have x to a power times x to a power, so we'll add the exponents. 12 plus 3 is 15. And that would be our answer. Let me erase that. Now if I have x to the 12th over x squared. There's actually a property for this, but I don't like the property. It's much easier to think of it another way. Note, if you have x to a power over x to a power, subtract the smaller exponent from the larger exponent, and you have x to that new power where the larger exponent was located. Okay. Note on exponents. We'll have another one. Notice here we have x to a power over x to a power. So we'll subtract the smaller exponent from the larger one. 12 minus 2 is 10. And we're going to have x to the 10th power where our larger exponent was, which is up on top. And we never leave blank in a fraction, so we put a placeholder of 1 down there. And x to the 10th over 1 is x to the 10th. Now if I had this, x to the 3rd over x to the 10th. Well, we got x to a power over x to a power, so you subtract smaller exponent from larger one. We got 10 minus 3, which is 7. So we're going to have x to the 7th where the larger exponent was. The larger exponent was down below in this problem. So we're going to have x to the 7th here, and we never leave blank in a fraction, so I put a placeholder of 1 there, and that would be our answer. So that's how you handle it when you got the same variable on top and on the bottom. Let me erase those. And we got one more property that we want to focus on. X squared y to the 3rd to the 5th power. Now this should have been called the distributive property of exponents. It's not, but that's what it should have been called. And it says if everything inside the parentheses is either multiplication or division, and the parentheses being raised to a power, then you can take everything inside individually to that power. If everything inside the parentheses is either being multiplied or divided, no addition or subtraction, and you're raising the parentheses to a power, you can take everything inside of that power. So we'll take the x squared to the 5th power, and we'll take the y to the 3rd to the 5th power. So we're going to have x squared to the 5th power, and we'll have y to the 3rd to the 5th power. Now at this point, we're raising one exponent to another exponent, so you multiply them together. 2 times 5 is 10, and 3 times 5 is 15. And that would be our answer. A lot of people don't know when to use this. This is a common mistake people will make in algebra here. They'll see this right here, and they'll rewrite it as x to the 2nd power and 3 to the 2nd power, and they get x squared plus 9. That is not correct. Reason why is I said if everything inside the parentheses is either multiplication or division. This is addition, isn't it? It's not multiplication or division. What we have to do here is you have to rewrite it as x plus 3 times x plus 3. And then you multiply it from there. So that's what should have been called a distributive property of exponents. Let me erase that. Now, next section, rational exponents and radicals. Let me grab another drink. We talked about evaluating nth roots. Remember the third roots, cube root? Let's look at one example a little bit bigger. Fifth root of 160. Well, whenever you're simplifying radicals, you always write to prime factorization. If I look at 160, that's 2 times 80. 2's prime size circlet. 80 is 2 times 40. 2's prime size circlet. 40 is 2 times 20. 2's prime size circlet. 20 is 2 times 10. 2's prime size circlet. 10 is 2 times 5. 2's prime size circlet, and actually 5's prime size circlet. So this becomes fifth root. We got 5 2's and 1 5. Now this number in the slot right here, that's called our index, and that's a 5. That tells us we're looking for a set of 5 of something. Well, if you notice, we got 5 2's. So those 5 2's are going to come out in front as a single 2. And we're left with a single 5 inside. So this would be our answer. You can only bring a number out if you got 5 of them, in this case. Now, next thing they're talking about is evaluating expressions of this form. So let's talk about that. First, let's talk about square roots. Square root of 7. Now I can rewrite this in fractional power form as 7 to the 1/2. That's called rational exponents. So you'll hear me refer to as fractional power or rational exponent. Now the number in the slot here, that's called your index. If you do not have a number there, it's by default 2. If I were to put a power on a 7, that would be a 1. So to go from radical form, this is called a radical, specifically a square root. To go from radical form to a fractional power, rational exponents, whatever power is right here goes up on top. And whatever number's in this slot, that's your index, always goes on the bottom. If I had the cube root of 5 to the 5. Well, remember, if I were to put a power here, it would be 1. So I could rewrite this. This would be 5 to the 1/3 power. Again, whatever power is right here goes up on top. Whatever number's in your slot here, that's your index, goes down below. Now you can have variables of that type, like this right here, x to the 5th root of x squared. This becomes x to the 2/5. Again, whatever power is right here goes up on top. Whatever number's in the slot is what goes on the bottom. Now you might have problems going the other way. So if I have x to the 1/7 power, and I want to put that back into radical form, this would be the 7th root of x to the 1st, going backwards. Whatever number's in the denominator there, that goes in the slot, that's your index. Whatever number's up on top is your power, and it goes right there. And then that become the 7th root of x. Now where this comes in with simplifying is sometimes you may have a problem that is in fractional power form, and especially with a number. And that's what this is actually referring to. You see the A refers to it being a number. So 1 over n is this right here. Well, we have to put it back in the radical form. So this would be the 4th root of 16 to the 1st power. Again, whatever number's down below here, that's your index. And whatever number's up on top here, that's your power. So we got the 4th root of 16. And if I were to do the tree breakdown for 16, I got 2 times 8, 2's prime size circlet. 8 is 2 times 4, 2's prime size circlet. And 4 is 2 times 2. And both of those are prime size circlet. Which means we have 4 2's. Now our index is 4, which means looking for a set of 4 of something. Here's 4 2's. So those 4 2's are going to come out in front as a single 2. And that's our answer. Now that's the first part. That's simplifying it when it's other form, a to the 1 over n. So let me erase this. Then we'll look at another type. Got 8 to the 2/3 power. This is the other type. This is where you got a number to a fractional power, but it's no 1 or a 1 up on top. So this is simplifying a number to a fractional power where the numerator is greater than 1. Step 1. Put the numerator on the outside of a set of parentheses. Step 2. Rewrite what is inside the parentheses in radical form. Step 3. Simplify the radical. Step 4. Simplify what is left. Okay. Step 1. Put the numerator on the outside of a set of parentheses. So our numerator is the 2. So we're going to rewrite this as 8 to the 1/3 to the 2nd power. Now when you take the 2 and put it on the outside set of parentheses, you don't never leave blank in a fraction, so we always put a 1 there. Step 2. We're going to rewrite what's inside the parentheses in radical form. The 8 to the 1/3 becomes the cube root of 8 to the 1st, based upon what we've talked about already. Step 3, simplify the radical. So cube root of 8. Well, if I did the prime factorization, 8 would be 2 times 2 times 2. Now our index is 3, so we're looking for a set of 3 of something. Here's 3 2's, so those 3 2's are going to come out in front as a single 2. And the 2nd power that's on the outside carries down. Now step 4, simplify what's left. 2 squared would give us 4. And that'd be our answer. Now we've already talked about simplifying radicals. So really there's nothing new there. Now let's get down to section R.5. First thing it talks about is a polynomial. And I won't go over the key elements of a polynomial. We've already looked at adding and subtracting polynomials. Let's get down to multiplication. So multiplying polynomials. Let's say we have negative 5x times x squared minus 7x plus 1. Notice that we have a single term out in front. So we're going to take that negative 5x, and we're going to multiply it times each term inside. So I'm going to have negative 5x times x squared. We'll have the negative 5x times negative 7x, and we'll have the negative 5x times 1. So we're going to follow the lines to see what to multiply together. This is a distributive property. So that gives us negative 5. X times x squared is x to the third. Negative 5 times negative 7 is 35. And x times x is x squared. Minus 5x times 1 is 5x. And that'd be our answer. Now if I had x plus 2 times x minus 1. Notice in our first parentheses we have 2 terms, second parentheses we have 2 terms. So we're going to use the line method again. We'll take our first term in the first set of parentheses, and we'll multiply it times each term over here. Then we'll take our second term in the first set of parentheses, and multiply it times each term over here. So again, I'll follow the lines what to multiply together. X times x, x times negative 1. And then we'll take the 2 times x, and we'll take the 2 times negative 1. Now x times x is x squared. X times negative 1 is negative 1x. 2 times x is 2x, and 2 times negative 1 is negative 2. Always combine together like terms. Negative 1x plus 2x gives negative 1 plus 2 gives us 1. So 1x or x, and then a minus 2. Now this is a polynomial. Polynomial, you don't have variables in the denominator. You either have x to a power or y to a power or a mixture of variables with a number in front. Standard form says your terms have to be arranged from largest power down to smallest. So notice how I have second power, the first power, and then my constant term. The number that's in front of your x, or x squared, is your coefficient. Like our first problem here. This negative 5 that's in front of the x to the third, that's our coefficient. 35 would be our coefficient of what's in front of the x squared. This is 3 terms. And 3 terms means it's what's called a trinomial. 1 term is a monomial. 2 terms, these are 2 terms right here, are binomials. And then a polynomial is just a general term to apply for all of them. Your degree is your largest power of x. There's a little bit more to that, but for college algebra, that's the definition that works best for us. So the degree of this first one here is 3. The degree of this second one is 2. We talked about this one earlier, where I'd have x plus 3 squared. And we said we just can't square the x and square the 3 because of the addition there, the plus. So we have to rewrite this as x plus 3 times x plus 3. And we use line method again. So we'll take the x here and multiply it times the x over here and times the 3. And then I'll take this 3 and multiply it times the x and multiply it times 3. Now follow the lines to see what to multiply together. So x times x, x times 3, 3 times x, and 3 times 3. Now there's another way of thinking of that. When you're multiplying binomial times a binomial, where you got 2 terms times 2 terms. You can multiply your first terms together. This is the first terms in each set of parentheses. You can multiply your outer terms together. That would be this x times this 3. You can multiply your inner terms together, 3 times x. And then you can multiply your last terms together, the 3 here times the 3 here. X times x is x squared. X times 3 is 3x. 3 times x is 3x, and 3 times 3 is 9. 3x plus 3x is 6x. You always combine together like terms. And that would be our answer. Now, I don't cover FOIL a lot. I like to show one example of it, but I like the line method because it doesn't matter how many terms you have. For example, if I had something that looked like this right here. We had x minus 1 times x squared minus 7x plus 2. Don't turn that up. Sorry, my wife is on. Turn the TV up. So I take my first term here, and I'll multiply it times all three terms over here. Then I'm going to take this negative 1 and multiply it times each term over here. So I'm going to take x times x squared. I'll take x times negative 7x. And I'll take x times 2. And then I'll take negative 1 times x squared. Negative 1 times negative 7x. And negative 1 times 2. Now some people try to FOIL this. You can only FOIL it when you have two terms and two terms. X times x squared is x to the third. X times negative 7x is negative 7x squared. X times 2 is 2x. Negative 1 times x squared is negative x squared. Negative 1 times negative 7x is positive 7x. And negative 1 times 2 is negative 2. Always combine together like terms. Here we have an x squared. Here we have an x squared. Negative 7x squared and negative 1x squared gives us negative 8x squared. Here we have an x and here we have an x. And so we have 2x plus 7x is 9x. And then the minus 2 carries down. Now let me double check that. 9x minus 2. Okay, so that would be your answer. That's 4 terms. Degree is 3, and since it's 4 terms, it'd just be called a polynomial. Remember, monomial is 1 term, binomial is 2 terms, trinomial is 3 terms, then it's just generally called a polynomial. Terms are again separated by pluses and minuses. Now it says identify and simplify special case products. The only one that's really important is that one I've been mentioning. I've already shown you an example of it. X plus 3 squared. There's some formulas for those other ones, but if you just write them out like this, then you don't need to memorize the formula. Let's take a look at multiplying radical expressions. Let's say we got square root of 5 times square root of 5. If your indexes are the same and you're multiplying two radicals together, what you do is you multiply what's underneath them and put them underneath a single radical. So square root of 5 times square root of 5 becomes square root of 5 times 5. And then you want to simplify it. Well, this is a square root. This is implied 2 is the index, which means looking for a pair of somethings. Here's a pair of 5s, so that's going to come out in front as a single 5. That will always happen. If you're multiplying square roots together and they're the same, they'll always cancel each other away in this manner. So for example, if I have square root of x times square root of x, well, this would give us x. Now this is assuming that our x represents positive values, because we can't have negative values inside of a radical with an even index. But for the most part in college algebra, you don't worry about that and you assume that your variable is positive. Now that's multiplying a single radical times another single radical. You can have a radical, that's square root of x, times and then square root of x plus square root of 2. So you can have a mixture. This is the same idea as when dealing with polynomials. We're going to take the single radical here and multiply times each separate radical inside. So we're going to have square root of x times square root of x plus, and we'll have square root of x times square root of 2. Now square root of x times square root of x is x plus, and remember, if you got a radical times radical, you can multiply what's underneath them. So we got x times 2, which simply gives us the square root of 2x. Remember, you can only bring something out of the radical if there's, well, outside the square root if there's a pair of them. Okay, let's take a look at another example. We got square root of x plus 1 times square root of x minus 3. Notice how we have 2 items here and 2 items here. Well, this is what we talked about before, where you take your first item here times the first item over here. You take this outer item here times this outer item over here. You take this inner item here times this inner item over here. And you take this last item here with this last item here. FOIL, or you can follow the lines. So we got square root of x times square root of x. We got square root of x times negative 3. We got 1 times square root of x, and you got 1 times negative 3. Remember, the square roots are the same, they cancel each other, so that gives you x minus 3 square root of x plus 1 square root of x minus 3. Now, we talked about combining together like terms before. We said if you have the same variable, the same power, you add or subtract the numbers in front. Well, you can have like items. It doesn't matter what you're dealing with. If they're exactly the same except for the number in front, here's square root of x and here's square root of x, then you can combine them together if you're adding and subtracting. And how you do that is you add or subtract the numbers that are in front of them. We got negative 3 plus 1, that gives us negative 2 square root of x minus 3. Now let's get into section R.6, factoring. Let me clear that off. And should have been checking to see if anybody's over here. Nope, nobody yet. Okay. So factoring. Our first method is GCF. And that stands for greatest common factor. Our second method is grouping. That's when you have 4 or more terms. Our third method is PSD. And that's when it's got the form x squared plus bx plus c. Our fourth method is key number. And that's when you got the form ax squared plus bx plus c. Our fifth method is dots. That stands for difference of 2 squares. And that's when you got 2 terms with a minus between them. Our sixth method is difference of 2 cubes. And that's when you got 2 terms with a minus between them. And our seventh method is sum of 2 cubes. And that's 2 terms with a plus between them. Now they also refer to a general strategy to factor it. That's mainly what we're going to focus on, where we're going to decide which method to use. They also say to factor out negative and rational exponents, so we'll talk a little bit about that. So let's look at our first example. Let's say I got 3x minus 9. Now we got two terms here, and when we're talking about numbers, we look for the largest number divides into both of those. We got 3 and 9, the largest number divides in both those is 3. Now factor means to divide out. So 3 divided by 3 is 1, and the x remains, minus 9 divided by 3 is 3. And typically you don't leave a 1 there, so that's 3 times x minus 3. Now this one has a note that goes along with it. Note on GCF. If your first term is negative, then you always factor out a negative. Now we're still on our first technique here. I haven't got past that, GCF. I notice that they're both divisible by 4, and my first term's negative, so I'm going to factor out a negative 4. And remember, factor means to divide out. So negative 4 divided by negative 4 is 1, and then the x carries down. And 16 divided by negative 4 is negative 4. So we're going to have negative 4 times x minus 4. Let's say I have x to the third minus 2x squared plus 3x. We looked at how to handle numbers, how to handle negatives. If all of your terms have x to a power, for example, or any variable to a power, this has 3 x's, this has 2 x's, and this has 1 x. I want to factor out the most x's I can, but you can't factor out 3 x's if this one only has 1. It's always your one with the smallest exponent. And you might say, well, there's no exponent there. Remember the first power, so that's x the first. So I'll factor out an x, and I always tell people to visualize this if you're learning it for the first time. X to the third, you got 3 x's sitting on the table. Somebody comes and takes one of your x's. You got 2 x's left. Minus 2, we have 2 x's sitting on the table. Somebody comes and takes one of our x's, so that leaves us a single x. Plus 3, we only have 1 x. Somebody takes that 1 x away, and there's no x's left. And this would be our answer. Now let me erase that. And let's say I have this problem. I have ax plus bx minus 7a minus 7b. GCF. There is none. Some have x's, some have 7's, some have a's, some have b's. But if you look at all 4 terms, they have nothing in common. Start going down through our list. Next one says grouping. You try that when you have 4 or more terms. Well, we have 4 terms here. Now with grouping, we're going to group first 2 terms together, and we'll group last 2 terms together. Now our first 2 terms, our first group, we take a look at it, see if they have a GCF, and they do. They both have an x. So I'll factor out an x. And that gives us a plus b. Then we look at our second group, and we'll look for the GCF. Well, they're both divisible by 7, and the first term is negative. So I'll factor out a negative 7, and that gives us a plus b. Now your goal with grouping is to get this parentheses the same as this parentheses, which they are. So I'll factor out an a plus b. Now to see what goes in your second set of parentheses, you can go up to the previous step and cross out what you factored out, the a plus b's. And what isn't crossed out goes here. So that'd be x minus 7. And that's our answer. Now let's say I have x squared minus 18x plus 80. Now GCF, there isn't one. Grouping is when you have 4 or more terms. We only have 3 terms here. PSD, that's when you got to form x squared x, no x, and there's no number in front of our x squared. X squared x, no number in front of our x squared. So this would be PSD. Now with PSD, we take the number at the end, ignoring signs. We're working with 80. And we come up with 3 columns. We got our P column. The P stands for product. We're going to write all the products give us 80. We got 1 times 80, 2 times 40, 4 times 20, 5 times 16, 6 no, 7 no, 8 times 10. Now the S column, that means we're going to add these numbers together. 1 plus 80 is 81, 2 plus 40 is 42, 4 plus 20 is 24, 5 plus 16 is 21, and 8 plus 10 is 18. Now our difference column, we're going to subtract smaller from larger. 80 minus 1 is 79, 40 minus 2 is 38, 20 minus 4 is 16, 16 minus 5 is 11, and 10 minus 8 is 2. Now the number we're looking for is always a number in a middle term. So we're looking for 18. 18 is in the S column right here, which means we're going to use 8 and 10. Now the last thing we have to determine is what our sign is going to be. And we have a note that helps us with that. Note on signs for PSD key number. The larger number that we are using in the P column is always the same sign as the middle term. If the number we circled is in the S column, then S for same signs. If it is in the D column, then D for different signs. S for same signs. They're both positive or both negative. Different signs. That means one's positive, one's negative. Okay. We're using 8 and 10. The larger those the 10. It will be the same, always be the same sign as the middle term. Middle term is negative, so the 10 will be negative. The number I circled is in the S column, S for same signs. Since this one is negative, then this one has to be negative. And that's our answer. Let me make up another one. Okay, so we got x squared plus 18x minus 40. Let's see, GCF. We got 3 terms. They have nothing in common. Grouping is 4 more terms. Well, this is 3 terms. PSD. PSDs are the form x squared x, no number in front of our x squared. So that fits. We'll take our number at the end, ignoring signs, and come up with our 3 columns. We'll write down all products give us 40. We got 1 times 40, 2 times 20, 4 times 10, 5 times 8. The S column, we're going to add those. 1 plus 40 is 41, 2 plus 20 is 22, 4 plus 10 is 14, 5 plus 8 is 13. Difference column, we'll subtract smaller from larger. 40 minus 1 is 39, 20 minus 2 is 18, 10 minus 4 is 6, 8 minus 5 is 3. Number we're looking for is again 18, which is right here, which means we use 2 and 20. Now our larger number in the P column we're using, which is a 20, will always be the same sign as the middle term. Middle term is a plus. Now number we circled over here is a difference column. D for different signs means one will be positive, one will be negative. So since this one is positive, then this one will be negative. And that's our answer. Let me erase this. Now we'll look at the next type. We'll make up one. Let's say we got 6x squared. Can't read my own writing. Okay, 6x squared minus 13x plus 5. Now I start going through my list. GCF, well, all three terms have nothing in common. Grouping is 4 more terms. This is 3 terms. PST is close, except for there's a number in front of the x squared. Now key number, what we're looking for here is an x squared, x, no x, and there's a number in front of our x squared. So x squared, x, no x, number in front of our x squared. So there's going to be key number. We'll take our number at the beginning times the number at the end, ignoring signs. So 6 times 5. That gives us 30. Now write down all products give us 30. We got 1 times 30, 2 times 15, 3 times 10, 5 times 6. Add them. 1 plus 30 is 31, 2 plus 15 is 17, 3 plus 10 is 13, 5 plus 6 is 11. Subtract them, smaller from larger. 30 minus 1 is 29, 15 minus 2 is 13, 10 minus 3 is 7, 6 minus 5 is 1. Just like the PST, we're still looking for the number in a middle term, 13, but we got 2 13s. There's a little note that helps us on this. If your last term is positive, the number you're looking for will always be in the S column. If the last term is negative, it'll always be in the difference column. Well, we got a positive here, which means our number will be in the S column. So we're going to use this 13. Now that note always applies on PST and key number, so you don't have to actually create both columns here. I will just for completeness sake. So we're going to use 3 and 10. Now before we just wrote our answer down, but here we'll do something a little bit different. First term and last term carry down. And we're going to rewrite our middle term using these 2 numbers. Now all of our notes on our sign still hold true. The larger number, we're using 3 and 10, so the larger one we're using is a 10, will always be same sign as the middle term, which is negative. Number I circled in the S column, S for same signs. Since this one is negative, then the 3 has to be negative. We're going backwards, combining like terms. Then we want to factor by grouping. So group first 2 terms together, group last 2 terms together. The first 2 terms are both divisible by 2, and they both have an x. And that gives us 3x minus 5. Now our last group doesn't have anything in common, but notice my first term is negative, so we're always going to factor out a negative. And if nothing else, you can always factor out a 1. You always want to factor out some kind of number. Now our goal is to get this parentheses same as this parentheses. So I'll factor that out. And that leaves us 2x minus 1. And that's our answer. Let me grab a drink here. Make up one more of those. Okay, so let's say we got 16x squared minus 22x minus 3. Double check that. Okay, 16x squared minus 24x minus 22x minus 3. GCF. There isn't any. Grouping is 4 more terms. This is 3 terms. PST is close, except for there's a number in front of the x squared. This would be key number again. The reason why is because we've got an x squared, x, no x, and there's a number in front of our x squared. So we'll take our number at the beginning, the number that's in front of our x squared, which is 16, times the number at the end, the constant term, ignoring signs. So we've got 16 times 3, which gives us 48. We'll come up with our 3 columns, write down all products, give us 48. We got 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. Add them. 1 plus 48 is 49. 2 plus 24 is 26. 3 plus 16 is 19. 4 plus 12 is 16. 6 plus 8 is 14. Subtract them, the difference column. 48 minus 1 is 47. 24 minus 2 is 22. 16 minus 3 is 13. 12 minus 4 is 8. 8 minus 6 is 2. Now the number we're looking for is again a number in the middle term, 22, which is right here, which means we use 2 and 24. Now our first term remains as is. Our last term remains as is. The larger number that we're using 2 and 24, so larger of those is 24, will always be the same sign as the middle term, which is negative. Number with circles in the difference column, D for different signs. So if the 24 is negative, the 2 has to be positive. Then we're going to factor by grouping. The first group are both divisible by 8, and they both have an x. And so that gives us 2x minus 3. Now our last group doesn't have anything in common, but remember we can always factor out a 1. And that gives us 2x minus 3. Well, now they both have a 2x minus 3, and that's our goal, get those parentheses same. So I'll factor out a 2x minus 3, and that leaves us 8x plus 1. And that would be our answer. Let me erase that problem, or problems. And then we'll look at the next type. Say we got 4x squared minus 9. GCF. There isn't any. Grouping is 4 more terms. Well, we got 2 terms here, so that doesn't apply. PSD and key number are both 3 terms, so that doesn't apply. Dots. 2 terms of minus it. 2 terms minus it. That applies. So we're going to try to rewrite this as something squared minus something else squared. If you can get it to fit this form, then it'd be difference 2 squares. Now you take a look at each individual piece and you ask yourself what times itself gives you that. For example, 4 is 2 times 2. 4x squared, that's x times x. And for 9, that's 3 times 3. So we were able to rewrite it as something squared minus something else squared. I'm going to label this, what's inside the first set of parentheses is F for first. And I'll label what's in the last set of parentheses as L for last. And difference 2 squares is just a formula. It's F plus L times F minus L. Now everywhere we have an F, we'll plug in 2x, and everywhere we have an L, we'll plug in 3. So we'll have 2x plus 3 and 2x minus 3. And that's our answer. Now let's say I have x to the third minus 27. Now there's no GCF. Grouping's 4 terms, PSD and key number both 3 terms, so I get down to dots again. And this is incorrect, but let me show it. If I try to write it as something squared minus something else squared, when you think, okay, what times itself gives you x to the third, or what times itself gives you 27, you can't think of anything. So it fails. That tells you can't use difference 2 squares. But you'll notice dot says 2 terms of minus it, and difference 2 cubed says 2 terms of minus it. So it's very similar. We try to write it as something to the third power, though, minus something to the third power. We take a look at each individual piece, and you ask yourself what times itself gives you that. For example, x to the third, that's x times x times x. For 27, that's 3 times 3 times 3. So we were able to rewrite it in that form. I'll label this as F, what's in the first set of parentheses. I'll label this as L, what's in the last set of parentheses. This is the formula for difference of 2 cubes. So we're going to have F minus L times F squared plus FL plus L squared. Now everywhere there's an F, I'll plug in X, and everywhere there's an L, we'll plug in 3. So we're going to have X minus 3, X squared plus X times 3 plus 3 squared. And then you do a little bit of simplifying. So I got X minus 3 times X squared plus 3X plus 9. That always looks like you can go down further with PSD method there, but you can't. And our last method of factoring. Let's say I have this. GCF, there isn't any. Groupings, 4 more terms. This is 2 terms. PSD and key number are both 3 terms. This is 2 terms. Dots, 2 terms, but it says with a minus between them. This is a plus between them. And difference 2 cubes is also 2 terms with a minus between them. 7th one, sum of 2 cubes. 2 terms with a plus between them. That's what we have here. So we're going to try to rewrite this as something to the 3rd power plus something else to the 3rd power. Same principle as the last problem we just did. You ask yourself what times self gives each individual, what times self 3 times gives each individual piece. X times X times X gives you X to the 3rd. 2 times 2 times 2 gives you 8. So it fits the form. If it fits the form, that's when you can use it. I'll label what's in the first set of parentheses as F for first. I'll label what's in the last set of parentheses as L for last. This is the formula for the sum of 2 cubes. So it'll be F plus L times F squared minus FL plus L squared. Now we're going to go through. Everywhere I have an F, I'll plug in X, and everywhere I have an L, I'll plug in 2. So I got X plus 2 times X squared minus X times 2 plus 2 squared. And that gives us X plus 2 times X squared minus 2X plus 4. Now the we never got down to this last material, but I want to make sure I have enough time to show you this next topic. But I do have videos out there for it. If you look out here, in every unit, you'll see instructor YouTube supplemental videos. So if you click that link, then you'll see full-blown lectures. These aren't shortened, accelerated lectures you're getting in this presentation, but you'll see full-blown ones. And so this is where you can get a lot of different topics covered. Now, go back to Unit 1, and you'll see down here, which says McGraw-Hill Campus. And then there's a link here. If you click that, it'll come up, and you should see the book here, and then you just click the Alex link there. And that'll bring up the course. You'll have to enter in your access code and so forth the first time, and probably enter your email and so forth. But at that point, it'll take you straight in. Yours will not look like mine. I'm going to go in Student View to show you what yours looks like. Excuse me. And let's see, Alex is okay. Next. You get tired of clicking next on these, I think. I think there's a lot of next. Get started. Okay, take the tools tutorial. Next. Okay. Now, if you click here, this is where the textbook is, message center, and so forth. And see what's up here. Nothing, because my face is covering it. Settings, help to log out. It's there. Okay, get started. Now I'm going to skip the tutorial. I wouldn't recommend that for you, but I'm going to skip it. And skip this tutorial. Okay. Now it's talking about you've unlocked your initial knowledge check. Now when you do this knowledge check, you want to make sure you put the appropriate effort into it. Because what this does is determines where your level of knowledge is in mathematics. It'll take a little while to do the knowledge check. So if you go through and you don't take it seriously, and you miss most of the problems, it'll assume you need to cover every topic. So it'll may give you a whole slew of work to cover each week. On the other hand, if you know most of those topics, and if you take the knowledge check seriously, then what it'll do is it'll give you a smaller amount. So it uses artificial intelligence to determine what kind of work you should be assigned. So don't take it lightly. And see, start knowledge check. Okay, get down to here. Next. Next. Get started. And let's see, start knowledge check here. Now I'm going to skip knowledge check. Do not do this. Go through, put your best effort forward in doing it. Now here it'll ask me what kind of knowledge check I have, and I'll say I have a moderate knowledge college algebra. Okay, so then I click next. Continue. Okay, now this next, personal pie, select a slice to get more information. You click here, it tells you. Click here, it tells you. These are the different units, different sections. This is our first one, and you can see there's quite a few topics here. It gets less as the time goes on. The idea is most of this is review. So some of you find this week pretty easy because you know a lot of these topics. Some of you, if it shows you don't know very many of these topics, you'll have a lot to get done, and you'll find it very stressful. It gets better, so don't you see down here 55, 51, 76. It's just very heavy at beginning. Okay, now if I click start my path, or learning path, go to the timeline to see it. Move that out of the way. Oh, here's the timeline. Okay, next. It's very unforgiving, but want you to click all these next, got it. You're all set. Okay, start my path. This is what I want to show you. Once you get started, after you take your knowledge check, and then it says, okay, blah, blah, blah. I click start. Except for it probably wants me to click a next or something. Oh, next. Got it. Start. Okay. And then next. Got it. Get up here. Now I want to put the answer in for this. And let me put in 2/3. Check. Okay, I get it wrong. I can recheck it. Get it wrong, incorrect, and so forth, and talks about this and how you get down to that. Then continue. What it'll do is based upon you getting correct answers, you get so many correct and assumes you've mastered the topic. If you get wrong answers, it'll assume maybe you need to review first. So sometimes it'll give you extra work based upon you entering incorrect answers. Now, let's say I can't figure this out. This little envelope over here says message your instructor. If you want me to help you out with the problem, just click this. And I'll create a little YouTube video showing how to work the problem, and so you can get over that hurdle. It will kind of guide you through a lot of these. Now, if you do the drop down here, we got many more options available. You see the textbooks here. Message Center, that's where I'd email you back. Reports, gradebook. Gradebook's going to be over in Blackboard, so don't use this. This will tell you what you currently got, but then it'll eventually be transferred over to Blackboard once a week. Unless I can figure out how to do it automated. Every Sunday I'll transfer it over. And then you got your assignments. If I click assignments, it'll pop up here. And you see the different options here, telling us how many mastered and remaining, so forth. If I click learn, I'll pop up these topics here. And, okay, addition like that. Oh, here it is. I was looking for it. I knew there's a way. That little drop down here allows you to choose other topics. Like we're currently doing addition and subtraction of 3 fractions involving signs. If I just don't get that, you emailed me and asked me for help. Come over here, ordering numbers with positive exponents. So I come over to there. Now some of them will be unlocked, some of them will be locked. So don't think you can do any topic. Okay, so order the expressions by using choosing greater than, less than, so forth. Okay, click start. 3 to the 4th is 81. 3 to the 3rd is 27. But even more than that, we talked earlier in the video where if you got 3 to the power times 3 to the power, you add the exponents. So this would be an equals. Here, 3 to the 3rd times 4 to the 3rd. 27. Let's see, I'm just curious. 27 times 4 to the 3rd. 1728, and 12 to the 4th. Okay, so 12 fourth is much greater. So this would be less than. And 3 to the 4th, 81 times 4 to the 3rd. And then 12 to the 3rd. Okay, so this is going to be greater than. And then you click check. And then you see it's correct, and then you go to next, and you'll see that marked is correct there, and you go on the next ones. I forget how many of these you have to get right before it says you mastered the concept. Let's see, what is that? 4 times 9, 36, that's equal that. That's 8 times 4 is 36, that's 32, so this is greater than. Wait a minute, 8 times 4, 32. Okay. Drawing a blank. 2 to the 3rd times 4, 32. 2 to the 5th is 32 also. That one's an equals. That's curious. Makes me think I'm doing something wrong. 4 times 9. This is 8 times, that's 72. This is, it's going to be less than. One of them should be a greater than, I think. 4, 36. Let's see. Correct. 2 in a row, double credit. Click next. 2 to the 4th is 16 times 4, 64. I don't know what 2 to the 8th is. 256. So this would be a less than. 2 squared is 4 times 4 squared, 16. That's 64 again. 16 times 4. Too many exponents are all running together. 64. 8 to the 4th has got to be bigger than that. So that's less than again. 16 times 16. So that would be greater than. Okay. Now you see I did 3 in a row and I went ahead and finished that topic. So it thinks I've mastered that topic. Breathtaking. Continue my path. It says use arrows to see other topics to work on. So it assigns that to you. And again, I can do the little arrow to come over here. So don't think you have to go sequentially. If you get stuck on something, move on to the next topic. I thought that it shows some of them was locked, but maybe I'm wrong. Oh, these say locked. What do these first ones say? Okay, so these are unlocked, so I can choose any of those. But if I come over here to one of these ones that says locked, well, there it is. This one says locked. If I click this, it says lock topic. You're not able to work on this topic yet. Select other topics in the carousel to work on first. This is assuming you need to master other topics before you can even try to attempt that. That's why you'll find some of them locked and some not. Do not hesitate if you are struggling. Feel free to click that little envelope to ask me how to do a problem. That's why I'm here, is to help you out in whatever way I can. Anyway, I'm going to go ahead and stop the video. I usually go an hour and a half, and we're about an hour and 25 minutes into it. And then I answer any questions you have not being recorded.